So hello students, now today you would have got these two questions of coordinate geometry. So I think you all would have found them to be interesting. कुछ तो different लगा ही होगा. Second question in particular has very important concept involved there. Those who would have solved, I will definitely say that's really good from my side. And first question is also a bit different. So let's start with it. The first question is, given that these two equations, this is which curve बच्चों? This is rectangular hyperbola whose center is 1 comma 2. Okay, and this curve, so it's a circle with variable radius, intersect at 4 points A, B, C and D. If centroid of this triangle lie on this line, then locus of D is. Okay, so let's start. See, how did I approach it? Looking just by looking at this equation, I replaced x minus 1 by capital X and y minus 2 by capital Y. So the equation of rectangular hyperbola, we get it in the form of xy is equal to 5. Okay, and then the equation of circle is x square plus y plus 4 whole square is equal to r square. Okay, see now what I will say, okay, see if I replace here x by y here, so you get from this equation, see we have to find actually the points of intersection. It is given that these two curves, the circle and rectangular hyperbola, meet at 4 points, they intersect at 4 points A, B, C and D. So to find the intersection, what do we do? So of course we go for the simultaneous solving both the equations. So from here I would like to put capital X by 5 by y in this first one. So you get it as 25 y square plus y square plus 8y, and then this is 16, I believe, yeah, is equal to r square. Now take LCM, you get y raised to the power 4 plus 8y cube plus 16 minus r square times y square plus 25 equal to 0. Okay, see you got a 4-degree equation in y. So actually that was expected. Why? Because we have 4 distinct points, it's given here. So we will assume that let capital Y1 comma capital Y2 Y3 and Y4 be its roots. Now I will like to find this relation, sum of the roots. Simple, no? Y3 plus Y4. How much is it? So it's minus 8. But we need the locus of the point D. So if I assume it to be, see, the equation given actually is in terms of small x and small y. So we need every result in small x and small y. So now if I substitute capital Y by small y minus 2, so it will be small y1 plus small y2 plus small y3 plus small y4 minus 8, because every time I am substituting capital Y, I'll be substituting it by small y minus 2 is equal to 0. So minus 8 minus 2, minus 8 minus 8 get cancelled both the sides. So we get y4 here. Okay, so which is like my y1 plus y2 plus y3 can be replaced by minus y4. Now why am I doing this? You will come to know just in a moment. और या हो सकता है आप लोग समझ गए हम कर क्यों रहे हैं, क्योंकि बात है सेंट्रॉइड की. सेंट्रॉइड के कोऑर्डिनेट्स क्या होंगे? x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So that's why I try to guess this sum y1 plus y2 plus y3 by 3. Now similarly I will put y is equal to 5 by x here. Okay, so I will put y is equal to 5 by x here. So how much will that be? X square, and this is 5 by x, so 1 by x square, and 5 plus 4 times x whole square is equal to r square. Now when you solve it, so you take LCM, x is power 4 plus 5 plus 4x raised to the power 2 is equal to x square r square. There is no term of x cube. You can see this here. So this implies sum of roots x1 plus x2 plus x3 plus x4. How much is it? So it's 0. So now if I put it in terms of small x, so we get from here x1 plus x2 plus x3 plus x4. Every time you will be substituting it by x1 minus 1, x2 minus 1, so you will get it as 4. So hence again I can write x1 plus x2 plus x3 as 4 minus x4. Now since the centroid lie on the line and centroid lie on the line, y is equal to 3x minus 4. So therefore, instead of y, I'll be putting y1 plus y2. Of course, you all would have understood. I'm assuming that coordinates of a, b, c are respectively x1, y1, x2, y2, and x3, comma y3. So this is equal to 3 times x1 plus x2 plus x3 by 3, and whatever we have as a constant minus 4. Now just put the value, you get the locus. So instead of this, we'll be substituting it by minus y4. So it's minus y4 by 3 is equal to 3 gets cancelled. So for this, I'll be substituting 4 minus x4 minus 4. This gets cancelled. So of course this also get cancelled. So since we need the locus for x4 y4, so that means I will be replacing y4 by y. So y is equal to 3x. That means the straight line is the answer. So I just found it interesting. That's why I thought to share it with you people. Now moving to the next question, which I think is far better a question and a good question as far as advanced level questions are concerned. So variable line passing through point P 1 comma 2 intersect this circle at A and B. Consider point Q on AB such that PA, PQ, PB are in HP. Find the locus of Q. Now see, what are we given? PA, comma, PQ, comma, PB are in HP. What does that mean? That means 2 over the mid of it is equal to 1 upon, because three numbers are in HP, that means their reciprocal are in AP bachcho. Okay, so using this, now observe here. See, that's how I started. PA, PB and PQ are distances along the line. Which line? The line that passes through the fixed point and this line and intersect, so along the same line from the fixed point. Okay, so again I'm repeating PQ. So let's say this is PQ here. So PQ is the distance of Q from the fixed point P, which happens to be 1 comma 2 if I'm not wrong. PA is the distance of A from P along the same line, and PB is again the distance from the same line. So whenever, wherever, that's what I always say, whenever you need a distance along the line from the fixed point, I always suggest to start with what? The parametric form of the equation of line. So I will be starting with x minus 1 over, since slope is not given, it's a variable line, so it's hence a variable slope, y minus 2 by sine theta is equal to r. Now what is r? R is the distance of any point on this line from the fixed point 1 comma 2. Fine. Now just get x and y. So any point will be r cos theta plus 1 on this line in terms of variable theta r sin theta plus 2. Now A and B are since points on the given circle. So to get the point of intersection, to get A and B, we need to substitute this point, because I will claim that for some r, of course this a point should satisfy the circle. So let's put it in the circle. So r cos theta plus 1 whole square, r sin theta plus 2 whole square is equal to 1. Now simplify it. So what do we get? R square, and this is 2r times cos theta plus 2 sin theta, and 4 plus 4 I suppose, isn't that? Plus 4 equal to 0. Now what? See, as expected, we got a quadratic in R. Why? It was expected because we had two such points A and B. So of course we need to have two such distances, PA, which I may suppose as R1, and PB, which I will suppose as R2. Okay, now see, PQ. So PA is R1. So what we actually need is 2 by PQ is equal to 1 by R1 plus 1 by R2. Now if you simplify it, you get it as, in the numerator, sum of roots, in the denominator, product of roots. So from here, as you can see, sum of root is how much? Minus times cos theta plus 2 sin theta, and product of root is a constant, which is 4. So now let's it's minus 2 times, I'm sorry, yeah. So therefore, and see, PQ, we have to find the locus of the point Q. So Q is the variable point s comma k, so whose distance has to be a variable distance. So I'm assuming to be r. So I'll put it as 2 by r is equal to, which is r1 plus r2. So r1 plus r2 is nothing but minus 2 times cos theta plus 2 sin theta over 4. This get cancelled. So now see, 4 is equal to minus r cos theta and minus 2r sine theta. Now go back here, you can see that was a variable point x comma y. So for r cos theta, I can substitute x minus 1. So 4 is equal to minus times x minus 1. And from here, r sine theta is nothing but you take it this side. So of course, see, that's what I'm saying. X is r cos theta plus 1. So how much is r cos theta? X minus 1. Similarly, r sin theta is y minus 2. So minus 2 times y minus 2, and that's it. So that's the locus. Okay. So 2y plus x, and this is 1 and this is 4. So I think this is equal to 1. So that should be the answer, bachcho. So that was a question based on use of parametric form of equation of circle, bachcho.